I'm going to introduce another term. In this case, it's a confidence interval. And a confidence interval is an interval estimate that is computed from sample data using a method that's designed to capture that population parameter a certain percentage of the time. So the most common confidence interval you'll hear about is a 95% confidence interval, which will contain the true parameter for 95% of all samples. And that 95%, that's the confidence level. We could set it differently. It doesn't have to be 95%. It could be 90%. It could be 99%. Sometimes you do an 80% confidence interval. So you can pick any confidence level. And it's basically how confident you want to be able to be. Sort of how often you're willing to make mistakes as well. Because if you're 95% confident, then you're kind of 5% not confident. So I'm going to show you some stuff with confidence intervals in StatKey. So we're going to use the sampling distributions section right now. And it doesn't really matter if I choose mean or proportion, it's the same idea. I'm going to pick proportion because I've mostly been talking about proportions so far. And maybe I'll move my video so it's a little bit easier to see what's going on. Because we've got some important stuff over on the right-hand side. So right now I have a data set and it's about college graduates, and I can see that the original population proportion was 0.275. So in the population, 27.5% of people have college degrees. And if I click this button over here that says generate one sample, this is going to take a sample of size 200 and it's going to figure out what percent of the people in that sample have a college degree. So it found that 62 out of the 200 people had a college degree, and so that sample proportion is 0.31. So this is that resampling from the population. So I'm going to generate another sample. I'm going to click the generate one sample button again. Then this one, it took a sample of size 200, and it found 54 people in that sample had a college degree for a proportion of 0.270. So this is how I could build up a sampling distribution. But the other thing that I want to look at here is there's a tab that says data tables and then one that says confidence intervals. I'm going to click on the one that says confidence intervals. And by default, it says 95% confidence intervals, okay. And I can see a dark black line in the middle of the plot, and that is at the true population proportion of 0.275. So you might be able to see a really light P in the middle there. And then each of these bars represents a confidence interval. The first one, that's the 0.27 that we just found. So you can see that it's really close to that middle line. And then the one lower down is that first sample that we found, which I think was 0.31. And so the circle in the center, that is our point estimate from our sample statistic. And then the green bar is a confidence interval that was computed from that sample. So if I click the generate one sample button again, I'm going to get another sample drawn from the population. I'm going to get a different sample proportion, and this one looks like it is even closer to the line, 0.265. So it is really close, and that interval also crosses the true line. So now, instead of just clicking the generate one sample button, I think I'm going to be lazy and I'm going to click the generate 10 samples button. And so what that's going to do is it's going to go to the population, it's going to take a sample of size 200, compute the proportion, put a dot on the plot. It's going to go take another sample of size 200, compute the proportion, dot on the plot. It's going to do that 10 times, but really, really fast. So I'm going to click the generate 10 samples button. Ooh. And now I'm seeing a distribution build up. It's starting to look like a sampling distribution over on the left-hand side in the big graph. And then I can see more confidence intervals appearing on the right-hand side. And it looks like one of those sample statistics, the sample proportions that I found, it was pretty extreme. It was almost 0.2, maybe it was like 0.21. And so that was really far from the population proportion. And when we created that 95% confidence interval for that statistic, we found an interval that does not contain the true population proportion. So this is what it means to have a 95% confidence interval. 95% of the time, if you take a sample and you compute the confidence interval, you'll find an interval that contains the population proportion. But sometimes you find one that does not. In this case, we have tuned our confidence level so that 5% of the time, approximately, we're going to be making a mistake. So right now you can see it says coverage 12 out of 13 is 92.3%. So that's not exactly 95%, but we've only taken 13 samples. So maybe I'll be lazy and click that generate 10 samples button again. Ooh, now I'm getting a better distribution in my sampling distribution, and I'm seeing more confidence intervals over on the right-hand side. Now my coverage is 95.65%, so that's pretty close to 95%. I'm going to click the generate 10 samples button again. Ooh, I still haven't found another one that did not contain the true proportion. Maybe I'll be even lazier and click the generate 100 samples button. So that's going to add 100 samples to my plot. Right now I only have 33 dots on my dot plot, or 33 confidence intervals. Now I'm going to have 133. Ooh, that distribution is looking even more symmetric and bell-shaped. And now I have a lot of confidence intervals on my plot. And I can see that quite a few of them don't contain the true proportion. It looks like 126 out of the 133 do contain it, so my coverage is 94.74%. Again, pretty close to 95%. The 95% is like long term if you took infinitely many of these, but right now it looks pretty good. So I think I'm going to take a screenshot of this and put it in my slides. All right, so I just want to make sure that I highlight a few things here for you. So one is the reason why each of these samples was of size 200 is because it says choose samples of size n equal 200. So one dot on this plot, like this one right here, this represents taking a sample of size 200, finding the sample proportion, which in this case, it looks like it's maybe 0.31, right? Something like that. And then putting a single dot on the plot. So every single one of these dots on the plot represents a sample of size 200. Then here, the 133, that is the number of samples that we've taken. And if I take more samples, I'm going to get a more and more symmetric, bell-shaped distribution here. The confidence intervals, each one of these, like this, for example, that represents one sample statistic, p hat, and then using the margin of error to go plus or minus and create that 95% interval. And it looks like about 95% of the intervals contain the true value. So the parameter is fixed, but the statistics vary from sample to sample. And because those statistics vary, the confidence intervals vary. And about 95% of intervals will contain the parameter. Again, I know this is really abstract, so please bring questions with you to synchronous class.